Okay, question 11. During photosynthesis, light energy is absorbed by photosynthetic pigments in the chloroplast. State one fate of the light which is not absorbed by the photosynthetic pigments. So we've got our leaf. Okay, we have light hitting the leaf. And either gets absorbed, bounces off, or goes through. That's your three fates of light. So we've got absorption, reflection, and transmission. So not the absorption, so reflected or transmitted. Describe the effect of absorbed light energy on the pigment molecules. Okay, basically what we have here is that they excite electrons and produces high energy electrons. That's it. Okay, so they produce high energy electrons. You may, if you're doing physics or chemistry, you might talk about that in a more precise way. You might be saying that you're promoting electrons into higher energy levels. Anything as long as you're actually explaining that it's the electrons that have now picked up energy. Okay. Plants contain several pigments including chlorophyll A, chlorophyll B and carotenoids. Explain the advantage to a plant of having more than one type of photosynthetic pigment. Okay, so this is the idea that if this was your absorption from your 400 to 700 nanometers, if we take chlorophyll A, which is a pattern, something like that, okay, then all of this chunk here is not being absorbed particularly well. So if I bring in chlorophyll B, which has an absorption kind of similar to A, but not quite in the same places, and then if I bring in carotenoids as well, then I have kind of absorptions into here. So all of these then add up to meaning that I've got good absorption here, and here, and here, and also into here, and into here, and into here. And then we've got a dip in the middle, which is my greenness, but up here is all good as well. So explaining the advantage, you're saying that it broadens the absorption spectrum that you can have, okay? Or that you can absorb a lot more different bits of light. Following photolysis, hydrogen is transferred to the coenzyme NADP. Name the source of this hydrogen. Don't know why I was having a problem with that one. That's water. Okay, that's the splitting of water. Describe the role of the NADPH in the Calvin cycle for carbon fixation. Okay, so you need to know all of the carbon fixation cycles. So let's just draw a little scribbly one. RUBP, which is your 5 carbon. Is connected onto carbon dioxide by Rubisco, which creates an unstable 6, which then snaps straight away into 3s. The 3s that you get are, getting this the right way around, 3PG, okay? 3PG is then converted into G3P, which you can pull off one of these for every cycle you go around, and eventually you can make this into glucose. Well, not eventually, you just need 2. Okay, so your NADPH is coming in here. Going back to NADP. And your ATP from first stage, is also coming in here. Might as well actually add a little one in here because you've also got some ATP being used to do that final conversion back. That's the whole cycle. Okay, so there you're asked the role of NADPH in Calvin. And so this is where we are. So what does NADPH do? It helps or allows or does the conversion from 3PG into G3P. Okay, so that's what it is. The role of NADPH is to provide hydrogen for the conversion of 3PG into G3P. I'm afraid that's quite a lot of work for a mark. You need to know your stuff. Sorry, phone pinging. Okay, and that's the question. Done.